Hello, my name is Kevin Lin, and my project is on the electrolysis of copper. First, what is the electrolysis of copper? Electrolysis is the chemical decomposition produced by passing an electric current through a liquid or a solution. In this case, copper sulfate is decomposed into copper ions and sulfate ions, where at the cathode, copper ions combine with two electrons to produce solid copper. So why is this important? During traditional mining procedures, copper ore usually contains about 0.5 to 2% copper. With electrolysis, we're able to produce almost pure copper, which is essential for power generation, electronic circuitry, and marine infrastructure. Thus, the question is proposed, how can the efficiency of copper electrolysis be increased? Light could have an effect on electrolysis. An increased intensity of light means that more reactant molecules will have the necessary activation energy for the reaction to occur. This is proved where Bidden and his colleagues studied the effect of sunlight on the electrolysis of water and found that exposure to sunlight led to a 53% increase in reaction rate. Thus, I hypothesized that if the intensity of light directed towards the copper electrolysis increased, then the rate of electrolysis will also increase. These are materials used in the experiment. And it was set up in the following picture, where the current and voltage was recorded for each trial. This process of electrolysis was repeated in a dark environment, under a 70-watt light bulb, under a 150-watt light bulb, and in direct sunlight, where each lighting conditions were repeated 10 times. Now, the amount of copper was calculated using Faraday's constant. By multiplying current by the time and dividing by the constant, it gives you the total number of electrons transferred, where if you divide it by the number of electrons transferred in the reaction, it'll give you the amount of copper is produced. And the results show that increased luminosity does lead to an increased total amount of copper produced, where direct sunlight produces as much as 16.5 milligrams of copper, as shown in the image. And by doing significance testing, it showed that between the control and the UV light and the control and the direct sunlight, there is a statistically significant difference between the trials, using an alpha level of 0.05. Thus, we find that normal light does not have a statistically significant difference, while under UV light and direct sunlight conditions, it leads to a statistically significant difference compared to the control trial and leads to 5% increase in copper production and a 20% increase in copper production, respectively. Thus, we can conclude that the null hypothesis is rejected and the alternative hypothesis accepted, where the intensity of light increase results in an increase in electrolysis. According to the copper report, copper demand is expected to double by 2035. In order to meet this demand, we have to increase the efficiency of copper production, and sunlight can provide a way to increase its efficiency without requiring human intervention. Therefore, electrolysis can support the future by increasing the amount of copper that is produced. Here are my references. Thank you.